Hey Sierra, how are you?
I'm good. How are you?
How was your weekend?
It was good. A lot of studying.
Studying. What about the big social life?
I can't, not this week.
Not this week?
Finals.
Okay. I'll make up for it this weekend.
Yes.
All right. How do you feel heading into your final?
Pretty good. It's impossible for me to get a B. I need like 108%. And
Okay.
in order for it to drop, I have to get like a 54. So I'm not too worried about it.
Have you gotten a 54 before on your test?
Um, no.
Okay. So you're not going to
Lowest
get a
I've done is like
54.
58.
You're not going to get a 54, so it's not going to drop.
Yeah.
Now, is there any chance, like if you get, that really good score that the teacher can micro adjust up to the next letter?
No. You won't.
Okay. Has he said that?
Yeah.
Okay. All right. Well, you know
I
what you're
sent
up
you like a
against.
bunch of stuff.
Yes.
So we'll just go through whatever we can get through because it's a lot.
Sure. Do you want to prioritize any of it or
Um, I think intermediate value theorem. I think I sent you
okay?
one on that, and probably related rates as well. Let me see.
Do you know which number?
It's like 26. So one of intermediate 25 and 26. Yeah, it's like kind of at the end, I think, of them, end or beginning.
Right. So one of these I'm struggling with is the Google uploads these in the order they were taken by date. I guess it's all here. I'm just not seeing. Oh, there it is. All right, now I'm seeing it.
Okay.
All right. 20, 26.
Yeah.
Okay. All right. Let's get started.
Okay.
All right. So question says explain why the intermediate value theorem applies in the given interval, then find an approximation value C, which f of C is exactly equal to the given Y value. Okay, did you calculate well, f of one and then f of four have to be calculated?
I did not do that. This isn't my test actually. I threw my test away on accident. So this is
Okay,
somebody else's.
you don't have to explain to me what you did or something do. I am not the judge or jury of anything. Um, so the answer here is that it's eight. So these are different values. So the intermediate value theorem, and this is not calculus, by the way. This is just like a calculus thing. Is that in order for you to go from 5 to 8, you have to hit every number along the way.
Okay.
There's no way to not pass through like 7, which is the example they're giving you. So they're
Okay.
looking for some words to that effect. It's like uh, it's like if you're driving 40 miles per hour and later on you're driving 50 miles per hour. Did you go 45 miles per hour?
Yes.
Yes, you did at some point. Maybe even more than once, but you did at least once.
Okay.
So that's the intermediate value theorem that you hit 7 at some point.
Okay.
So that's why it applies. Then you have to find the approximation for the value of C in the corresponding open interval. Okay, so you're basically just solving to figure out where this equals 7. Um, so you're setting that function equal to 7
Okay. X minus 2 squared.
and solving for X. Again, this is not calculus. So you're going to subtract 4 from both sides. You're going to take a square root of both sides, plus or minus the square root of 3 equals X minus 2. Add 2. So X equals 2 plus or minus the square root of 3. But maybe only one of these is in that interval from 1 to 4. And which one is it?
Wait, what do you mean which one?
You know, which there's two answers here.
Oh, the 2 and the plus or minus 3?
Yeah,
Um, aren't they both in it?
no.
Then
2
the,
minus the square root of 3 and 2 plus the square root of 3.
oh, 2 plus, right?
Yes,
Okay.
looks right to me.
So the answer is 2 plus square root of 3?
Yeah.
Okay.
Okay, that is it for that.
That's good.
Uh, you want to go on to 27?
Yeah.
Okay. All right, so could you factor the top and the bottom, please, if you haven't already done that?
Yeah. Okay, for the top, I got 2 times x minus 1, and then x plus 2 times x minus 1.
Okay. So the thing that is useful here is to make sure you remember. Well, it's not really asking. So what is it asking for? Okay, so it's discontinuous wherever the bottom equals 0. So at x plus 2 equals 0 and x minus 1 equals 0, but -2 and +1.
Okay.
And then
Go ahead.
show algebraically. Yes, we've done that. All right, determine whether it has a limit and or not. So it's kind of weird the way this is been asked. So the hole, this graph has a hole. Do you remember that from pre-calculus?
Yeah.
It's a hole when x minus 1 equals 0, so x equals 1. Holes generally have a limit that's defined. So
So why
like,
is it x minus 1 and not x plus 2?
because x plus 2 doesn't cancel out with the top and the
Okay.
bottom.
Okay.
So f of x, when it's reduced, is now 2 over x plus 2.
Okay.
So the hole is at x equals 1. The y value is from putting 1 back in for x. So that's 2/3, like that.
Okay.
All right. Now, we want to find the limit as x approaches 1, f of x. Now, because it's a hole, you can actually just say it's 2/3.
Okay. Okay, that makes sense.
So then, but the other one though is the limit now as x approaches -2. But this one you really are supposed to break apart as a left and a right limit because it's a vertical asymptote. So you're supposed to find the limit as x approaches -2 from the left, limit as x approaches -2 from the right.
Okay. And how do we know it's a vertical asymptote?
So because there's nothing that cancels out with the what's over here on the top,
Okay.
this is where the bottom equals 0.
Okay.
So I mean, a couple ways to do it. Are you allowed to use a calculator to graph?
I don't think so.
Okay. So you want to pick a value like you pick a value that's to the left of -2, so like -2.001. You put that in for x. It's 2 over -2 plus -2.001 plus 2, which is
0.001.
yeah, so it ends up being negative infinity. And this one over here would be like -1.99999.
Okay.
That ends up being positive infinity. So because it ends up being 2 over 0.00001.
Okay.
All right. Number 3, part C. Part C here.
Okay.
Any questions on that?
No.
Okay. All right, so write an equation for each vertical and horizontal asymptote of the graph. So I already have one, x equals -2.
Hmm.
And then the function here, some calculus, you can use L'Hopital's rule, but you used to look at the degree of the top and the bottom to decide if it was top heavy or bottom heavy. This one is bottom heavy. It's got the degree bigger on the bottom. So this goes to y equals 0.
Yeah. Okay. Wait, actually, where did you get y equals 0? Sorry.
All right, is that okay, or do you need more explanation for that?
No, I got that. That's good.
Okay. Okay. Do we need to do 28?
Yes, please.
Okay. All right. So you always try just putting the number in. This one's tough though because you're like x goes to a. Well, ends up being a squared minus a squared on top, a to the fourth minus a to the fourth on the bottom, 0 over 0. Now, before you learned any calculus, you had to factor. Now you can use L'Hopital's rule, or you can still factor. What would you do you think?
Um, I think I would do L'Hopital's rule.
Okay, that's a good choice. So you take the derivative of the top. What's the derivative of x squared?
2x,
2x. A is a constant, so you can ignore it. It's 0. What's the root of x to the fourth?
4x cubed.
You can simplify. So this becomes the limit as x approaches a, 2 over 2x squared. Sorry, 1 over 2x squared. And then you put
Okay.
a in for x. So that becomes 1 over 2a squared.
That's it?
That's it.
Oh, perfect. Okay.
All right. Tell me where to go next. There's a lot here.
Um, I guess number 21 with like it's a piecewise function.
Okay, let me see if I can find it. There it is. Find the value of a that makes the function continuous at every x. I think they meant the value of k. Value of k. Okay. So you always start by just putting the number in, the two in for x.
Okay.
So you get minus k times 2 squared plus 5 equals 2 times 2 squared plus k times 2 minus 7. So that's 5 minus 4k equals 8 plus 2k minus 7. So 5 minus 4k equals 1 plus 2k.
And is it just algebra from there?
Yep,
Like,
it's all for k.
okay.
You end up getting k equals 1. No, that's not right. 6k equals 4, k equals 2/3.
Yeah.
No calculus. Like what you've sent over doesn't have any calculus yet.
Okay. And then um hold on, let me see where to go next. Um oh, like the epsilon stuff.
Do you really believe that's going to be covered on your
Yeah, he told us specifically it's gonna be. He said it's
really?
not on the AP test, but it's gonna be on the
No, it's
final.
not. Okay. I don't see that question. Let me get to it.
Um, it's like problem number 4. I'm pretty sure.
I have to look these up because these are never used in real life. All right, here we go. And you think it'll be this problem or one like it?
I'm pretty sure it's the exact same problem on the final.
Okay. All right, let me do a quick search on these.
Okay.
All right. Like this example. What's on the paper there is not correct. Um,
Yeah.
So we know that the limit as x approaches 4, 1 plus 2 to the 4 minus x equals 1 plus 2 to the 4 minus 4, 1 plus 2 to the 0, which is 1 plus 1, which is 2. Is that okay so far?
Yes.
All right, so we know that. And the way this works is you do the absolute value of f of x minus L. L is the limit, by the way. That's L.
Okay.
Is less than epsilon. Is that okay?
Yes.
So now we know that the function is 1 plus 2 to the 4 minus x, and this is a weird function that they're picking. Minus 2 is less than 0.8.
Okay.
Well, I guess we have epsilon, which is weird. Usually don't okay, usually they don't give you epsilon. Okay. Okay. Um, do you have any examples from class? Because your teacher's not doing a proof here, he's doing a different type of problem.
I don't, but if you don't know how to do it, I can call my cousin after this. He probably knows.
Well,
He
it's an
sits
odd problem.
with
It's an odd problem because of the way that it's structured with they're usually always linear when you do these, and you end up factoring out like this ends up having to factor out into a multiple of the original, which it's not going to.
Okay.
So typically, what happens here is that you don't get an epsilon. You have to find an epsilon, and your delta is defined as a function of epsilon. So this ends up this ends up this ends up becoming a multiple of the original, which it's not. And then they usually don't give you epsilon, which is why this is not working out as nicely as it should. So let me look, and I'm happy to look more on this. I don't know if you want us to use the time on that, but I can look a bit more to see if I can find something similar to this.
No, we can just move on.
Okay.
Like to the related rates problems, it's like 21, 22.
All right, let's look at that. Back in the other direction. Okay, so I see 22, which is like given the graph. Is that what you mean, or is there something else?
There's something. It's like there's related rates with like
Yeah, that didn't look
a
like
cone.
related.
Oh wait, they're not related rates. They're implicit like
What's the derivatives? Okay. Let me check the phone here because I'm not seeing them in the order. They didn't come in like an order. So you said 21. I see the London Eye Ferris wheel. I don't see I don't see that. There it is. Okay. The ladder and the cone.
yeah, the latter
Okay.
one.
There we go. maybe that was in a different grouping. Sorry, there's so many pictures here. I'm trying to get.
I know.
Okay, there it is. Okay, and then I upload differently. All right, do you want us to do the ladder problem or the cone problem?
The latter one, please.
13-foot ladders leaning against a house. Very exciting. So we got the ladder, 13 feet, starts to slide away. By the time the base is 12 feet from the house, it's moving at a rate of 5 feet per second. And we want to know how fast the top of the ladder is sliding down. Trying to find y prime, basically.
Okay.
Okay, so the overarching equation here is that it's Pythagorean theorem. It's a triangle. X squared plus y squared equals, in this case, 13 squared. Now that ladder is not changing size as it's sliding. That's an important distinction in this problem compared to a few others.
Okay.
So we do need to be able to solve for y. We don't have the height. It is 5 though. You get that from plugging in 12 squared plus y squared equals 13 squared. Solve for y and you end up getting 5. We'll need that later in the problem. So now you got to take an implicit derivative of this, related rate derivative. X and y are functions of time. So you've got 2x dx dt, or x prime plus 2y dy dt equals 0. And then you solve for the one that you're looking for, which is y prime. So
Okay.
this is really y prime, this is really x prime. So y prime equals minus 2x x prime over 2y. The 2's cancel. You get minus x prime over y. So you have to just plug in the indicated values. Looks like we got 12, 5, and then 5 there. So it ends up being minus 12.
Okay.
Units are feet per second. They're usually grading on that as well.
Yeah.
So you have to start with an equation. You have to take a derivative, solve for the indicated related rate.
Okay.
All right, part B is asking about the area of the ladder. So the area of the triangle. So the area of the triangle is 1/2 base times height. The base, though, is x, the height is y. Is that clear?
Yes.
Okay, so you have to be able to take a derivative of this, which is product rule. So it's the first times the derivative of the second plus the second times the derivative of the first, like that. So you've got all these quantities. X is, if you go back to the previous problem, X is the literal, how far away it is. It was 12. So y prime was minus 12. X prime is 5. Y is 5. Whatever that is, negative 144 plus 25 cut in half.
Okay.
Next is the angle between the ladder and the ground.
Okay.
So that's you actually have your choice of which trig function you'd like to use. I would recommend using one that doesn't relate x and y, because then you got to do another, product coefficient derivative, because the ladder isn't changing. So if you use like cosine of theta equals x over 13, derivative is not that bad. Derivative is minus sine theta, theta prime equals 1 over 13 x prime.
Okay. Cosine.
Now you got to solve for theta prime. It's x prime over 13 negative sine theta. Sine theta is because you got all the numbers here. It's 5 over 13. X prime was 5. This is 5 over 13. Those cancel, 5's cancel, you end up getting -1
Okay.
radians. It's in radians usually, or whatever.
Okay.
So hopefully that's clear.
Yeah.
You need to get one of those. You want to do the water?
I don't think so. Can we do 24 on the bottom of that page?
Yeah, the inverse derivative.
Yeah.
Okay. So you have to first figure out, well, there you go. So I know we had a discussion on this before. It's probably still not clear. You got to figure out where sine of x equals 1/2. That's on your unit circle, right? First
Yes.
quadrant, it's right there. It's at pi over 6. So x equals pi over 6. Um, it's actually also over here. I don't know why your teacher's. It's also at 5 pi over 6, but that's not in the interval. So I guess
Okay.
that's why your teacher's doing this. So you have to know that one. The formula for the derivative is 1 over the derivative at that point. So you have to be able to take the derivative of x, cosine x. So it's 1 over the derivative cosine of pi over 6, which is square root of 3 over 2.
Yes.
And then if you need to simplify, you could. You don't simplify, you told me.
Nope.
Especially when you know you can't achieve the grade you want.
Yeah.
You know, just make sure you put something down on every piece of paper, every problem.
Okay.
Main thing is this figuring out this from the beginning because it wasn't given. You have to, you're not taking the derivative at 1/2. It's whatever that x value is.
Okay. Wait. And how'd you get that x value?
Unit circle. Where's
The
sine of
pi over
x
2,
equal?
right? Wait.
Yeah. Yeah, where is
Okay.
it 1/2?
Okay. Yeah. Yeah. Okay. Let's see. Can we do derivative of, or like the definition of derivative as a function?
Like, is there a problem there you want us to look at or something?
Yeah, but I can just tell you the equation. It's f of x equals 2x squared minus 3x.
Okay.
And then we're just using the definition of derivative of a function.
That limit as h goes to 0, f of x plus h minus f of x over h. All right, so the first thing is you have to figure out what f of x plus h is. Because it's very tedious, it's expanding this binomial. So the faster you can expand it, the better.
Okay.
X squared plus 2xh plus h squared. Because you're really doing x plus h times x plus h. All right, so it ends up being 2x squared plus 6xh plus 3h squared minus 3x minus 3h.
Okay.
And then that's just this piece on the top. You're subtracting f of x, which is there, and then we're all dividing by h. So it's a lot of writing, limit as h goes to 0. So in the numerator here, it's all of this stuff minus the original function, which is in parentheses now, 2x squared minus 3x all over h. Now, the reason you can't just like find the limit is because you're dividing by 0.
Okay.
So, you got to keep going here. So you distribute this negative in. We'll show that here. It's actually not that bad when you can copy and paste.
Yeah.
It's worse when you got to do it freehand. So, what should happen is that anything that doesn't have an h will cancel. So like minus 2x squared cancel 2x squared, 3x cancels with 3x. And notice everything that's left on the top has an h in it. Hooray for us. We're gonna 6xh plus 3h squared minus 3h all over h. So you're actually dividing each of these by h. You still
Okay.
can't put h in for 0 because, well, you get division by 0, and that's bad. So finally you can put h in, or 0 in for h. You get 6x minus 3. Now that should look really familiar to you because you know calculus now, you know how to take derivatives.
Yeah.
What is the derivative of 2x squared minus 3x? Well, it's 4x minus 3. Clearly I missed something here. Oh, what did I miss? This is a 4. It's so sloppy. 4, 4. Sorry about that.
It's all good.
4, 4, and 4. Okay, that worked. And that's the derivative.
Okay.
Right. There are many
Okay.
other possibilities, but that is if you think that's the one, that's everything.
Yeah. Okay. Hmm.
You want to look at that epsilon delta thing? I just need to grab a book. No,
Yeah, sure. Because I feel like everything else that I sent you, I kind of already know.
be right back.
Okay.
I did not find what I was looking for, so I'm gonna look at another place.
Okay.
It'd be easier to show you a standard problem, but that's not what you have on your test.
A standard problem would work too, though, and I can just get the idea of it.
Okay. All right. So this is kind of a standard problem.
Okay.
The limit as x approaches -1, 4x plus 1 equals, and you get the limit by actually putting -1 in for x, right? So it becomes 4 times -1 plus 1, that equals -3. All right. So now you I don't want to say this. Um, you take the function and you subtract the limit. Okay. And so this is 4x plus 1 minus a -3. This becomes 4x plus 4. Is that okay so far?
Yes.
Now, the nature of these things is that you factor out this 4 and you get an x plus 1, with all an opposite value, by the way. And this is now less than some delta, and it's also between 0 and delta. You divide both by 4. Everything by 4 here. 0 divided by 4 is 0. So you have
Okay.
0 absolute x plus 1 less than delta over 4. You let epsilon equal delta over 4.
Okay.
So that is how you figure out your delta and your epsilon. This
Okay.
is not, I mean, your problem is kind of like this, except they're giving you epsilon, which you can solve for delta, kind of. That's where we're running into confused because it's not quite the same. It doesn't, you can't get it down to this nice um, form, but we can look at it one more time. Maybe we can. So let me go grab that problem.
Okay.
Does it all look familiar to what you're doing in class?
Yeah. I mean, it was like we did it in like August.
You can also do these on the calculator, which are kind of the way that it looks like it, because it does say plot the graph on your grapher. And
I
that's
don't know.
and that's where I was wondering, going to ask you if you guys had done that because that makes a huge difference.
I feel like we did plot it.
Let me see if I can find a picture of what we're actually doing. I had one up and I closed it. Uh, So this is the picture. So let me try to explain it for your problem. On your problem, I'll put some numbers in. This could help. This could maybe be the most useful thing here. So in your problem, x is 4. And notice you're trying to subtract this delta and add this delta, which we don't know. But we know the limit. We know the limit. We know that L we calculated earlier. It's 1 plus 2 to the 4 minus 4 power, which is ended up being 1 plus 2 to the 0, which is 2. So we know that this is 2. So this is 2.8 and 1.2. So what you're essentially trying to do is you would graph this. It does caves. So do you want me to actually graph it? Let's graph it.
Okay.
And then let's bound it. Wait, bound it here. So y equals 2.8. Y equals 1.2. Okay. And then we should put in an x equals 4. All right, there we go. We got everything we need to do this. Let's do some things here. All right, now we have it. All right, so in your problem, 2.8, this is y equals 2.8. This is y equals 1.2. So this width right here is the, if we go back up to the picture, it's the x minus delta, and this width over here is the x plus delta. And you can only get that through the calculator. So this is 4. So this width right here is 2.322. And then this width right here is 0.848.
Wait, how'd you find those?
Just the difference between the x values.
Oh, okay. Oh, okay.
That's what the teacher's looking for.
Okay.
This can only be done with a calculator, cannot be done by hand.
Okay. That makes sense then. Perfect.
All right. Anything else?
I don't think so. Thank you very much.
All right. Is this our last lesson for a while?
Yeah, till January.